Alright, here is the third video for systems of equations. So far we've talked about two main methods. One is graphing and the other is substitution. And this bears repeating because it's the entire sort of foundational basis for what we're about to do. The reason we were allowed to substitute, so if you had x equals y plus 2, and you had another equation like 2x plus y equals 4. The top equation here told you that whenever you saw x, you could replace it with y plus 2. And the reason is that equations represent equality, so x and y plus 2 are equal. And since they're equal, they're interchangeable. And so that allowed us to write this as 2 times y plus 2 plus y equals 4, and that gave us 2y plus 4 plus y equals 4, which gave us 3y plus 4 equals 4, which gave us that 3y equals 0, and so y equals 0. And substitution always allowed us to find one of the two variables, right? When you're substituting and you're replacing x with y plus 2, what you've done in effect is removed all x's from your equation. And so at the end of the day, you have to go back into one of the two equations, and if you have a substituting equation, it's always easier to do that one, and plug in your half answer to get the other half. And so x equals 0 plus 2, which is 2. And then at the end we always write our answer x comma y. And so there's our answer, 2, 0. So again, the main foundation that substitution is based on is the fact that when you have equality, the left side and the right side are identical. And so that's going to lead to our new trick, which is called elimination, and it utilizes the same fact. So sort of a brief explanation of what we're going to be doing is, if you look at the equation, say x equals 2 and y equals 3. If I asked you what x plus y was, well, you know that since x is 2 and y is 3, you can replace x with 2 and y with 3, so you could write that as 2 plus 3. But the net effect here is we just added the left sides of the equation to get the left side of a new equation, and we added the right sides of the equation to get the right side of a new equation. And so this is the foundation for elimination. And let me give you a tiny example. We have x minus y equals 3. And x plus y equals 5. If we do the same process where we add the top equation to the bottom equation, we add the left sides, x plus x is 2x, and 3 plus 5 is 8, then what we've done in effect is we've taken these two equations, combined them into one new one, just like we combined x equals 2 and y equals 3 into the new equation, x plus y equals 2 plus 3. And we've gotten rid of one of the two variables. And the reason that worked is that what was in front of y here and here were equal and opposite, so they canceled. If we keep moving forward, we get that x equals 4. And just like with substitution, when you eliminate, you get rid of a variable, and so you still have to solve for the other variable. So you need to pick one of the two. Let's go ahead and pick, if this is equation 1 and that's equation 2, let's pick equation 2 and write 4 plus y equals 5 and move the 4 over, and we get y equals 1. And we can check that. Right, so we did this in equation 2. Let's plug in 1 and 4 into equation 1. and we get 4 minus 1 equals 3, which is true, and so it worked in equation 1. And so our answer, remember our answer is always an ordered pair, x comma y, so our answer is 4 comma 1. Let's try another example. Negative 2x plus 3y equals 2, and 2x plus y equals 2. Alright, so we notice that the numbers in front of x are equal and opposite. Right? 2 is equal to, but opposite negative 2. So if we add, the 2x take away 2x cancels, leaving me with none, and 3y plus 1y, right, remember there's always a 1 there, is 4y equals 2 plus 2, which is 4. Dividing both sides by 4, we get that y equals 1. So now, when we come over here to do our little bit of side work, we need to figure out what x is. Pick an equation. Here's 1, here's 2. Let's be brave and do equation 1. Negative 2x plus 3 times 1 equals 2, which is negative 2x plus 3 equals 2. Move the 3 over, and we get negative 2x equals negative 1. Divide both sides by negative 2. And we get x equals, the negatives cancel, and we're left with 1/2. And so let's check equation 2. 2 times 1/2 plus y, which is 1, is 2. 2 times a half is 1, so we get 1 plus 1 equals 2, which is true. And so x equals 1/2 works, y equals 1 works, and our answer is 1/2 comma 1. Alright, so the two examples we just did were what we would call nice examples. They were made to work as quickly and easily as possible. So let's look at a not nice example. Let's instead look at what happens when they aren't opposite, and then let's look at what happens when they're not equal. So suppose I have x plus 2y equals 3, and x plus 4y equals 5. So here we have the case where the numbers in front of x, right, are both 1, but they're not opposite. So how do we make it opposite? Well, one thing you can do in an equation, right, in the back of your head you should think, well, if I have two sides which are equal, I can multiply both sides by the same number. Oh, that should be a B. And still get something that's equal. So what could I multiply x by so that it has a negative 1 in front of it? Well, if I just multiply everything by negative 1, that'll do it. It'll switch every sign. Right? And remember, you have to do to the left side as well as to the right. And so now we can actually go ahead and add. Right? 1x plus negative 1x cancels. 2y take away 4y is negative 2y. And 3 take away 5 is negative 2. Dividing both sides by negative 2, I get that y equals 1. Once we plug this into one of our original equations, for example, x plus 2 times 1 equals 3, gives me that x plus 2 is 3, which gives me that x is also 1. 1 is going to be my solution, and you can check that here in, this was equation 1, here in equation 2, we have 1 plus 4 times 1 does equal 5, and it works in both. So this is my answer. So this is the case where they didn't have opposite signs. Let's look at something where neither number matches. So I'm going to have 2x minus 3y equals 1, and 3x plus y equals 7. So here, the y's are opposite sign, but they don't have equal numbers in front of them. So I need to somehow come up with a better way of dealing with this. The way that I'm going to deal with this is, remember that again I can multiply both sides by anything I want. So if I multiply y by 3, 3 and negative 3 are equal and opposite, and then I just have to remember to multiply everything by 3 as well. And so what I get is, well, I'm going to rewrite my equations. 2x minus 3y equals 1, and 9x plus 3y equals 21. And so when I add, 2 plus 9 is 11, so I have 11x. My y's cancel, and 21 plus 1 is 22. Divide both sides by 11, and I get that x is 2. We plug into one of our two equations. Let's go ahead and plug it into the bottom equation. 3 times 2 plus y equals 7. 6 plus y equals 7. Subtracting 6 from both sides gives me that y is 1. And so my answer is 2 comma 1. We don't have to check the bottom, it's where we got y equals 1 from, but if we check the top, 2 times 2 is 4. Minus 3 times 1 is 1, and so I get 1 equals 1, which is true. So it all checks out. Let's try one last example. Leave a little bit more space this time. So here I have two equations, no signs are opposite, and none of the coefficients are equal. And so in this case you can pick. Either you can make the x's equal, or you can make the y's equal. I'm going to pick the y's because it's a little bit more work, but in either case you're going to get the same answer. So I need the number in front of y to be equal but opposite. So what I need to find is the least common multiple of 2 and 3, and that's 6. So 3 is going to really want a 2. So everything's going to really want a 2. And then 2 is really going to want a 3. So everything's going to really want a 3. But I have to be careful because I really need to make the bottom row have the opposite sign on the y. And so I can do that by, instead of multiplying by 3, multiplying by negative 3. So let's go ahead and rewrite. I get 4x plus 6y equals 2 times 13 is 26. And I get negative 3x minus 6y equals 3 times 7 is 21. And so when I add my 2, 4 take away 3 is just x. 6 take away 6 cancels, and 26 minus 21 is 5. Look at that, we got the answer actually right away. And so let's go ahead and plug that into one of the original equations. Let's do 5 plus 2y, that's equation 2, equals 7. 2y equals 2, which tells me that y equals 1. And so how do we write our answer? As 5 comma 1. And if you check back up in the top equation, you'll see that 2 times 5 is 10, 3 times 1 is 3, and 10 plus 3 is indeed 13. So the things I wanted you to see today, and the thing I hope you take with you, is that elimination is built on the fact that if you have two equations, you can add them to get a new equation. And the way you do that is you add the left sides and you add the right sides. We saw that sometimes it just magically works out that one of the numbers will go ahead, one of the variables will just go ahead and disappear. And when it does, you get your new equation and you solve for one of the variables. And you always remember to plug that into one of the original equations. That gives you the other variable. Here we saw it again canceled magically for us, and we got our answer and we plugged it in. Here we had to be more creative. They didn't cancel if we added, but if we multiplied one of them by -1, or if we multiplied one of them by 3, or if we multiplied one of them by -3 and the other by 2, we could make the variables have equal and opposite signs. Once they're equal and opposite, you can add them, they eliminate, and you're left with only one variable. So the key here, just like in substitution, is get only one variable. Once you get only one variable, you can solve. Everything else is pretty easy from there on out. So go ahead, do the homework. I'll see you in class.